Hi everybody, welcome to chapter 8, and here we have a fairly short chapter. We'll hopefully be done with it by next week, the middle of next week. And in the previous chapter, we've worked a lot with triangles, and we've found measures of angles inside triangles. We've found the lengths of the sides, and we've classified them and called them different names and everything. Well, now we're going to do the same thing or similar things, but we're going to use polygons. And that's what chapter 8 is all about. And then in chapter 10, we're going to do something similar to circles, or with circles. So today we're going to work on section 8.1, which is to find the internal angle measures in polygons. And we'll obviously talk more about that. Tomorrow, the 27th, we will finish off section 8.1 by finding the external angle measures in polygons, and then other people in the class will be retaking the chapter 7 test. On the block days, we're going to work on parallelograms, that's section 8.2, and Friday we're going to work on rhombuses, rectangles, and squares. And Monday, we'll have a review and then a quiz on Tuesday, and we will begin Chapter 10, Circles, on the next block days. So, a short chapter, should be fun. There's really no new ideas here. They're all very similar to what you learned in triangles, just a little bit of a different application. Okay, so we're going to do 5 things today. We're going to learn the names of the polygons. We're going to learn the difference between concave and convex polygons. We're going to learn how to draw diagonals in polygons, and those are going to come in very handy when we learn how to calculate the sum of the interior angles of a polygon. Remember, working with these shapes, it's all about angles and sides, So whether you're working with a triangle, polygon, a pentagon, a hexagon, or even it's a circle, it's all about the lengths of the sides and the angles. So, and then we're going to learn how to find the measure of a missing angle in a polygon. And all of this will be on the homework for tonight. Okay, let's learn the names of polygons. And most of these you already know, and so I'm treating this really as a review. But polygon, poly means many. Okay, so polygon is a general term for a shape with 3 or more straight sides. Okay, so a triangle is a polygon, and something with 100 sides is also a polygon. And then you might run into the term n-gon, which is a shorthand term for polygon when you don't know how many sides it has. So you might get a question that says, you have an n-gon with a total of 540 degrees. How many sides does it have? That might be a question you could see. So let's just review and write the name of the polygon in each shape. So obviously the first shape is a triangle. Okay, 4 sides. Triangle has 3 sides. A quadrilateral has 4 sides. So this is quad. Quad is the Greek for 4. Okay, quadrilateral. And then the name starts sounding really similar. So 5 sides is a pentagon. Penta is the Greek prefix for 5. Okay, and you might remember that huge building in Washington, D.C. where all the military people are, the heads of the military, and that's called the Pentagon, and it has 5 sides. Okay, 6 sides is called a hexagon. 7 sides, septagon. Okay, septa is the Greek prefix for 7. 8 you probably already have heard of, octagon. Think of an octopus. An octopus has 8 legs. Okay, octagon has 8 sides. 9 sides is called a nonagon. And 10 sides is called a decagon. See where the word decimal comes from that DEC prefix. So we have triangle 3 sides, quadrilateral 4, pentagon 5, hexagon 6, septagon 7, octagon 8, remember octopus, nonagon is 9, and decagon is 10. So please memorize these. This is just good general knowledge to have. And it's also good to know those roots, those Greek roots, because they come up a lot in math and basically all over the place in life. Okay. So we're going to learn the difference between concave and convex polygons. But first we need to understand what an interior angle is. And I'm pretty sure you already do from the triangle work. But just to be really clear. So the interior angles of a polygon are the ones that are on the inside. Right? So interior are the inside angles or vertices. Okay? So in the way we're talking, angles are the same thing as vertices. Okay, and those are plural, so the singular of angles is angle, and the singular of vertices is vertex. A little vocabulary there. So, when you have a convex pentagon, okay, all the interior angles are less than 180 degrees, less than 180 degrees. So each of these angles could be 120, could be 10, could be 90, but they all are less than 180 degrees. Now, just looking at it, okay, it's pretty easy to tell a convex pentagon because it's like a fence around a field or an area. Okay, all the lines come together, they meet, okay, and they make this this shape. And so that's called a convex pentagon. Now, when you have one or more interior angles that are greater than 180, so this angle here is greater than 180, okay, instead of the figure looking like the one on the left, which has, it's all kind of nicely surrounded by this fence, you have this kind of weird shaped figure with this kind of cave in it. And that's how I remember that it's called a concave pentagon, because it has a cave. Okay, it doesn't create, it doesn't, it's not like a fence that goes around a nice field, but it has this indent in it that kind of looks like a cave. Now, besides knowing what the difference is between the two, we're going to be working with and calculating angles and sides and things only for convex pentagons. But you need to know the difference between the concave and the convex, even though we are just going to be doing calculations with the convex. Okay, so now we're going to start trying to figure out how many degrees are in these polygons. And we remember that there was 180 degrees in any triangle, okay? But we now don't know how many are in quadrilaterals and pentagons, hexagons, septagons, octagons, etc., etc. So the way we figure that out is by drawing diagonals in the polygons. Now, let's look at a vertex of the triangle. And here's our definition of diagonal. A diagonal is a segment, so it's a piece of a line, remember that from the fall, that joins two non-consecutive vertices, okay? So if this is a vertex on a decagon, okay, this vertex here would be a consecutive vertex. Consecutive means next to. So what we're looking for is not next to vertices. Okay, but this vertex is not next to it. This one is not next to it. This one is, okay? So it is, you can't draw a diagonal to it because the diagonal would just be the side, but this one is not consecutive and this is not consecutive. And it turns out you can draw diagonals between those non-consecutive vertices. Okay, and that's what we're going to do. So for a triangle, we can start at this corner, this vertex right here, but we can't draw any diagonals because there are none, right? If I try to go to this, draw to this vertex here, that's the side. It's not a diagonal. And if I try to draw one to this vertex, that's a side. It's not a diagonal. Okay, so a triangle has zero diagonals. I'm going to shorten that to diags. Okay. And I'm actually going to change colors here. It'll look better. Easier to see. So, and we only count the diagonals from one corner, okay, from one vertex. So, if we look at the quadrilateral, I cannot draw a diagonal to this corner because it's a side. I also cannot draw a diagonal to this corner because it's a side. Okay, so those won't work. But I can draw a diagonal to that corner. And so the quadrilateral has one diagonal. One diagonal. And when you draw the diagonal, okay, what you're doing is you're cutting up the piece into triangles. There's one triangle there, and there's one triangle there. So I have one, two. I have two triangles, and that'll be really important in just a minute. Okay, so let's carve these other guys up and figure out how many triangles we have in each. Okay, so here's our pentagon. And I can draw a diagonal here, and I can draw a diagonal here. So how many diagonals is that? That's two diagonals. And how many triangles? 1, 2, 3. 3 triangles. And maybe you're starting to see a pattern here. Okay. So let's look at our hexagon. And just for kicks, we can go from this corner for a change. Remember, it doesn't matter which one, just as long as you only do one. There's 1, 2, 3. Oh, that's supposed to go over there. It's not a very good diagonal. Okay, so I have 3 diagonals. Okay, and I have 1, 2, 3, 4 triangles. Okay, so that was a hexagon. This is a septagon. Let's pick this guy here for a change. Do 1, 2, 3, and I hope you're doing this on your paper while I'm doing it here. Okay, and that's 1, 2, 3, 4 diagonals. And that's 1, 2, 3, 4, 5. 5 triangles. Now, I'm going to guess that this next figure is going to have 6 triangles. and that it's going to have 5 diagonals. Let's see. I'll start from here. 1, 2, 3, 4, 5. Sure enough. And 6 triangles. 1, 2, 3, 4, 5, 6. Okay, I'm going to bet this one has 7 triangles. This guy is going to have 8 triangles. And this guy is going to have 6 diagonals. And this guy's going to have 7. So we can go 1, 2, 3, 4, 5, 6. This one is going to have 7. Let's get rid of all this. One, 2, 3, 4, 5, 6, 7. Okay, we can count up our triangles. So I'm guessing that I'm going to have 7 triangles in this guy. 1, 2, 3, 4, 5, 6, 7. Okay, and I'm guessing I'm going to have 8 in the last one. 2, 3, 4, 5, 6, 7, 8. Okay, so hopefully you can all see the patterns. Now, when we're talking about how many degrees are in any one polygon, okay, and you know how many triangles are in each polygon, then think about and remember how many degrees are in each triangle. And hopefully you remember that there's 180 degrees in each triangle. Okay. So let's take this hexagon, okay, for example. So it has 3 diagonals, it has 4 triangles, and each of those 4 triangles have 180 degrees in them. Okay, so there's one triangle, okay, and it has 180 degrees. Okay, there's the other triangle. It has 180 degrees. This triangle has 180. And finally, this triangle has 180. Okay, so we have 4 triangles at 180 degrees apiece. 4 times 180 degrees equals 720 degrees. So all hexagons have 720 degrees. Okay, and it turns out that same calculation holds for all of these. So we can fill out a handy table. And we know a triangle, the first column, okay, first row is triangle, first column is number of sides, it has 3. A quadrilateral has 4 sides, pentagon has 5 sides, hexagon has 6 sides. And then the polygon that has 7 sides is a septagon. And a polygon that has 8 sides is called an octagon. Okay, remember from what we did on the previous slide, hopefully in your notes. So a triangle has 1 triangle, quadrilateral has 2, a pentagon has 3, a hexagon has 4, a septagon has 5, and an octagon has 6. So if we take the number of triangles, okay, and each polygon, and we multiply it by 180, you're going to have the total number of degrees, the sum of the interior angles in that polygon. So here, number of triangles is 1. We multiply 1 times 180 degrees. The sum of interior angles of a triangle is 180 degrees, and yep, we know that. Okay, so a quadrilateral, okay, it has 2 triangles in it. We multiply 2 times 180, so the number of degrees in a quadrilateral is always 360. The lengths can be any size you want. They can be infinitesimally small or they can be humongous. The length of the sides don't matter, okay? A quadrilateral will always have 360 degrees in it. And that's sometimes a little bit difficult to get your head around, but it's true. So a pentagon has 3 triangles, so 3 times 180 degrees equals 540. Okay, 4 times 180 degrees for a hexagon is 720 degrees. Okay, 5 times 180 degrees equals 900. And 6 times 180 degrees equals 1,080 degrees. A lot of degrees. Okay, so make sure you fill out this table correctly. It's going to come in very handy on things like quizzes and homework. So this is a very, very important table. So now we're going to use what we've just learned to how to find the measure of a missing angle. Come back here. How to find the measure of a missing angle, important word is missing, in a polygon. So let's look at the figure on the left-hand side. So the first thing we're going to do is figure out what kind of polygon we have. So we have 1, 2, 3, 4, 5 sides. So we have a pentagon. And if you go back to your table on the previous page, you know that the sum of the interior angles of a pentagon is equal to 540 degrees. And you also notice that this guy is missing. You don't know what x is. But you do know what all these other angles are. And that's what's important. Okay? So you know that the sum of all these angles, 1, 2, 3, 4, 5, is going to be equal to 540 degrees. Okay, the problem is you don't know what one of them is, but you guys can easily figure out what that one is. So let's try. So I know my total is going to be 540 degrees. So I can take away this. And there's a million ways you can do this, guys. I'm just doing it this way. So subtract. It's me 440. Okay, then I'm going to take away 117, 117. And I'm going to end up with 323. Take away 105. Left with 218. Take away 115. Okay, and I am left with 103 degrees. Okay, so when you take away all these 4 that you know, you subtract them from 540, you know x is equal to 103 degrees. Okay, pretty simple, huh? Okay, let's look at the other one. I'm going to erase this side. So if you want to pause this video and copy that down, that'd be fine. But I'm going to erase it now, so I have some room. for this other guy. Okay. Okay, so remember, first thing we do is count the sides. So I have 1, 2, 3, 4, 5, 6, 7. So I have me a septagon. 7 sides, and we know from our table on the previous page that pentagon 6 septagon has 900 degrees. Okay, so we kind of do the same thing, and we start at 900. Okay, we subtract the 120. Got 780. Okay, then we subtract 116, and we get 664. Okay, we subtract 129, and we end up with 535. Then we subtract 130, and we get 405. We subtract 135, we get 270. Then we subtract 125, and we come up with 145. So 145, okay, and my y is equal to 145 degrees. And that's it, okay? So tomorrow what we're going to do is we're going to look at these outside angles, the exterior angles, and we're going to do some work with them. But this gives you a good introduction to the interior angles. You should be able to do the homework pretty quickly. If not, you can ask me questions or our aide questions, or certainly any of your fellow student questions. And good luck.